All right, so now we just have another example where we're going to do everything we just did in the previous problem with the Lucky Lovers discount. If you want to pause the video, try it yourself before I do it, go ahead and try that. Here we go. As a head of inventory, you were thrilled to know that you shipped 2 computers to your biggest client the day the order arrived. Woohoo, you were so excited. However, you were then horrified to find out that someone had restocked refurbished computers and with new computers in your storeroom. So there's a possibility that your biggest client just got refurbished computers instead of new computers, so they're not going to be happy. The shipped computers were selected randomly from the 15 computers in stock. 4 of those 15 were refurbished. So that means 11 were new and 4 were old or refurbished. If your client gets 2 new computers, things are fine. Remember, you shipped them 2 computers. So if they get 2 new computers, no big deal, everything's fine. But if the client gets 1 refurbished computer, it will be sent back at your expense, $100, and you can replace it. However, if both computers are refurbished, the client will cancel the order this month and you'll lose a total of $1,000. So down here, it's asking us to come up with a probability model for the company's loss. So I'm going to use L for the company's loss. And I'm going to do the tree diagram in just a minute. But just to kind of give you an idea of what we're looking at here, the company's loss could be nothing if they got 2 new computers, $100 if they got 1 new, $1,000 if they got 2 old or no new. Now, the tree diagram is going to help me find these probabilities. Because I've got picks without replacement, I have conditional probabilities. And tree diagrams can help you with conditional probabilities. And if you feel like you can do it without the tree diagram, feel free to do it without the tree diagram. But the idea with the tree diagram is to make a branch for the first computer. The first computer could be a new computer or it could be a refurbished or an old computer. And what's the probability of each one of these events? Well, we have 15 total, 11 are new, so this is 11/15, and then that would leave 4/15 for the refurbished. Hopefully that makes sense. Now that's the first computer. Now the second computer could have 4 basically potentials. It could be new or refurbished, but it could be new or refurbished and the first one was new, or it could be new and refurbished while the first one was refurbished. So you kind of have 4 scenarios going on here now. Now these are conditional probabilities. So this is the probability of the second one being new, knowing the first one was new. So you already gave away a new computer, there's only 10 left and 14 total now. Or this is refurbished knowing the first one was new. So you have 1 less new, but you still have 4 refurbished. Still out of 14. All right, this would be new, but the first one was refurbished. So you still have 11 new, but out of 14. And this one is refurbished knowing the first one was refurbished. So now we only have 3 refurbished left out of 14 total. You always multiply across your branches when you're doing a tree diagram. So I have 11/15 times 10/14 for the first scenario. And let's just kind of round these off to the hundredths place. Obviously, the more you round to, the more accurate your answer will be. AP exam is not terribly concerned about that rounding. That should make sense that those are the same. I probably didn't have to multiply that in if I was thinking instead of talking. And then you kind of want to make sure that these add up to 1. When you round, sometimes you lose a little bit of that perfect 1. We're good here. So just kind of make sure, maybe you need to round 1 a little differently or go to another decimal place. All right, so now the company does not lose, remember this is loss, the company does not lose any money if the client got 2 new computers. So that was this possibility right here, 0.52, a little bit over than half of the time. The company would lose $100 if he got 1 new, right here, if the client gets 1 refurbished, so 1 refurbished and 1 new. That can happen in 2 ways, right here. This one's new refurbished, this one's refurbished new. Both scenarios are they got 1 new, 1 refurbished. So we add those together to get a 0.42 probability of $100 loss. And then if the company got 2 refurbished, this last scenario by itself, the company would lose $1,000. So yet again, I'm using techniques that I learned from the previous chapters to build this probability model, which we learned in this chapter, to find the expected loss. So this would be if we did this over and over and over again, what on average would be the company's loss. You take each individual outcome, you multiply it by the probability, and you add them up. Remember that formula is on your formula sheet. You do not have to have it. It is on your formula sheet. And type these in real fast so we can move on to the standard deviation. Make sure I didn't typo anything. And I'm getting the company's expected loss to be $102. The standard deviation of the company's loss is the square root of that variance formula, which is on your formula sheet if you can't remember it. But we take each individual outcome, we subtract the mean, we square that so that we don't have negatives and positives, multiply by the probability, add them up, and then take the square root to get the standard deviation. Remember, this formula alone would be the variance, okay? The square root sign would be how to do the standard deviation. So I'm going to open a second set of parentheses here for that parenthesis there. 0 minus 102 squared times 0.52 plus parentheses 100 minus 102 squared times 0.42 plus open parentheses 1000 minus 102 squared times 0.06. Close it for the end of the radical, and I'm getting a standard deviation of $231.94.